Back. Problem 3. Evaluate the limit if it exists. If the limit does not exist, type DNE, does not exist. Limit x approaching -5, 2x plus 10 over absolute value x plus 5. Absolute value always should tell you that left hand limit and right hand limit needs to be checked. Okay, let's see what this means. In our case, we have x approaching -5, 2x plus 10 over absolute value x plus 5. First, let's set x equals -5. Denominator I get 0. Numerator also I get 0. Which means I need to have a deeper understanding of the problem. Since there is an absolute value expression, it helps to consider limits from one side each. That is, one from the left hand side, one from the right hand side. Notice here I have factored out the 2 and I have x plus 5 inside. Okay, so look, I'm going to -5. Okay, so it helps to draw a picture what left hand side looks like and what right hand side looks like. Okay, now for the left hand limit, take a number close to -5 to the left. So to the left of -5 is a number close enough. So that would be -5.1. That's an example. Okay, so I plug in -5 plus 1 in my expression. Okay, -5.1. So what happens to the numerator is I have a -0.1 inside. Denominator is absolute value -0.1. Therefore, because of the absolute value, that negative becomes a positive. In other words, the negative from the top survives. So I have a -2 from the top. So that gives me an idea what's going to happen when I approach -5 from the left. It tells me 2x plus 10, that is 2 times x plus 5 over absolute value x plus 5. As x approaches -5 from the left, you see a negative on top is going to be -2. Now, let's consider the right hand limit. Take a number close to -5 to its right. Typo. Say, so how does a number close to -5 on the right look like? It looks like -4.9. Okay, so plugging it in, I get on the top a positive 0.1 and on the bottom, oh, it should be -4.9. Okay, I also get a positive. Why? Because it's absolute value after all. Denominator is positive no matter what. Is a numerator which I have to worry about. So these two cancel, I get a positive 2. In other words, when I approach -5 from the right hand side, my expression limit is 2. Okay, now positive 2. So since the left hand limit, that's -2, is not equal to the right hand limit, the limit does not exist. Okay, all right, next problem. Limit x approaching 0, x to the 4 cosine 2 over x. So this is a rather complicated looking function. Let's understand what's happening here. X to the 4 cosine 2 over x. If I plug in x equals 0, this becomes undefined and this becomes 0. You see? So 2 over x, as x goes to 0, goes to some kind of infinity, you see, positive or negative. But what do we know about cosine? We know that cosine function oscillates. Here is the graph of cosine. Starts at 1 and goes on and it oscillates. That means cosine of anything however complicated it look like, is less than or equal to 1. That's the highest height it goes is plus 1, and the lowest height it goes is negative 1. So cosine 2 over x is bounded between negative 1 and positive 1. Let's multiply by x to the 4 throughout. When we multiply inequalities by something, we have to keep in mind that we are multiplying by something positive, or rather non-negative. If you multiply by a negative, inequality changes. Okay, that's the catch. But fortunately, fourth power makes sure that you are multiplying by something non-negative. That is, the inequality is maintained. So negative 1 times x to the 4 is negative x to the 4. Positive 1 times x to the 4 is x to the 4. And the inequalities are maintained. So now when you take limit x approaches 0 of these expressions, you have limit x approaching 0 of negative x to the 4 less than or equal to limit x approaching 0 of cosine 2 by x less than or equal to limit x to the 0 x to the 4th. Notice the end functions as x approach 0, the limits are 0. In other words, my limit is bounded above by 0 and below by 0. This calls for what is called the squeeze theorem or the sandwich theorem, and you get limit x approaching 0 cosine 2 over x to be 0, 0. All right. So until next problem.